Right, so we're going to work on lesson 88 today. Before we start, I want to make sure that you have read page 558 and 559. And you want to try and work through this with me on paper so you have examples when you're working on your written practice. We're going to start on page 559 with problem A. All right, it says at the top to use the statement below to answer problems A through B. So this is the statement they're talking about. It says tomorrow 32 students are attending an award ceremony. Each table will seat 5 students. It says how many tables can be filled. Okay, so we're going to go ahead and start by drawing some tables. So here's one table, here's another table. We'll make 7 seats or 7 tables. Okay. Now it says tomorrow 32 students are attending an award ceremony. Each table will seat 5 students. So let's go ahead and put some 5 students in each of these. There's 5. Let's count while we're doing this. We've got 5. Now we've got 10. There's 15. There's 20. There's 25. There's 30. Now there's only 32 students. So I guess this last table is going to have 2. And that puts us at 32. Okay, so it says how many tables can be filled? Well, let's look because there are only 5 per table, so we're going to look at the ones that have 5. So we have 1 table that's filled, we have 2 that's filled, we have 3, 4, 5, 6 tables that are filled. This table is not filled. It's only got 2, so it's not filled. So the answer to this question is how many tables can be filled is going to be 6 tables. Now, that's a long way to do it. We could also use division because we're dividing 32 students into groups of 5. So we could do 32 divided by 5. Figure out what that is. So I'm going to use a long division to solve this. So let's go ahead and do 32. I'm using my lines to help guide me. And I know that from doing this thing here that there's 6 tables filled. So 6 times 5 is 30. 7 times 5 is 35. That's too much. So we're going to go ahead and put 6 here. 6 times 5 is 30. And we're going to subtract, and we're left with 2. So the answer to 32 divided by 5 is 6, remainder 2. Now, if you'll notice, this 6, the quotient without the remainder, is how many tables are filled. The remainder, this number here, you'll notice, is what is on that last table. So if you understand that, you don't have to draw a picture. You can just use your long division, and it's much quicker than drawing a picture. Let's go ahead and go to B. It's the same thing at the top. It says use the statement below to answer problems A and B. Tomorrow, 32 students are attending an award ceremony. Each table will seat 5 students. How many tables will be needed? Well, on A, we drew this picture, and we had 6 tables filled, but then there was a 7th table that wasn't filled. So I'm thinking that 7 tables is going to be our answer for this one. How many tables will be needed? It's going to be 7 tables. So our answer is 7 tables for B. Okay, going on to C. We have some new directions here. It says use the statement below to answer problems C through E. And so this is our statement we're going to use. It says Tendai found 31 quarters in his bank. He made stacks of 4 quarters each. How many stacks of 4 quarters did he make? Well, let's draw some stacks. So we've got These are stacks of quarters. I'm going to draw a few here. Let's draw 8 stacks and we'll see if that is enough. So we're going to put 4 quarters in each. There's 1, 2, 3, 4. 1, 2, 3, 4. Let's write these. We got 4, 8. This is going to be 12. 1, 2, 3, 4. 16. 1, 2, 3, 4. 20. Oops, messed up on that. 20. 1, 2, 3, 4. 24. 1, 2, 3, 4. Then we've got 28. 1, 2, 3, 4. And then, well, we're only going to 31. So this one here is only going to have 3. And this is going to be 31. Well, right, only 3. So remember, all the rest of these have 4 in them. All right. How many stacks of 4 quarters did he make? Well, let's count them. We've got 1, 2, 3, 4, 5, 6, 7 had 4 quarters, and one of them had 3. So there was only 7 stacks that had 4 quarters. So our answer would be, how many stacks, 4 quarters did he make? It would be 7 stacks. And you could draw a big picture like that. That's a pretty good idea. But there's an easier way. Remember, we're breaking 31 quarters into groups of 4. So we could do 31 divided by 4, just like we did on problem A. We did 32 divided by 5. So 31 divided by 4. So let's go ahead and solve that. 31 divided by 4. Well, I know that 4 times 7 is 28. That's pretty close. And 4 times 8 is 32. That's too big. So we're going to go with 7. 7 times 4 is 28. We subtract, and we're left with 3. There's nothing else to drop down, so that's our remainder. 7, remainder 3. And if you look closely, you'll notice that 7 stacks is the same as our quotient without the remainder. And the remainder is this last table over here with only 3 people on it. Okay. So let's go ahead and go to problem D. It's the same deal. It says we're going to use the same statement. How many extra quarters did he have? Well, let's go back and look. We had extra quarters right here. This was a stack of only 3. So there were 3 in that extra stack. Didn't make a stack of 4, so it would be 3. There were only 3 extra quarters. So how many extra quarters did he have? Well, he had 3 extra quarters. So we're going to go ahead and mark that as 3 extra quarters. And we can move on to the next one, which is E. We're using the same statement as the last 2. If Tendai made a short stack with the extra quarters, how many stacks would he have in all? Well, let's go back and look at C. So we want to know how many stacks he has. Well, we've got 1, 2, 3, 4, 5, 6, 7 stacks with 3 quarters, and then we have 1 stack that's only got 3 quarters, but this is still an 8th stack. So we have 8 total stacks, 7 of them with 4 quarters, and 1 of them with 3. So if Tendai made a short stack with the extra quarters, which we know is 3 quarters, how many stacks would he have in all? Well, it would be 8 stacks. And that's it for this lesson. I hope you guys learned something. I'll do a little smiley face for you guys. All right. Have a good day.